This video is for Unit 5, Target 2, quantitatively analyze impulse and momentum when a system experiences an outside force. So what this target is covering in terms of the types of problems is when there is a net force on the system, there is an outside force. Momentum is not conserved. The system experiences an impulse. The system is not isolated. It's all these things where we've gone in there, we're messing with the system. This is also quantitatively, so we're going to be relying on this equation for pretty much everything. So, which is the impulse, which is force times time, is equal to the change in momentum. So impulse is just change in momentum. So change in momentum is the final momentum minus the initial momentum. So the basic problems with these is where you're going to be given some numbers, you need to plug them in. So for instance, a baseball comes in and is thrown, and a batter hits it, and we know the incoming velocity, we know the outgoing velocity, we know the mass, and maybe we know the time of contact, and we want to know the average force, and does it break the bat or something like that. Another one could be maybe someone falling down, a gymnast sticking a landing, and if it takes them a certain amount of time to land, and their feet exert so much force, we measure with a force plate, maybe what was their initial velocity right when they hit. It's taking the information from a problem and then applying it to using this equation, impulse equals change in momentum, to find the answer. One thing you want to watch out for is this minus sign right here. Remember, it's the final velocity minus the change in velocity, and force has a direction. Velocity, both final and initial, both have directions, so you need to account for that with your numbers, with the positive and negative sign, which in terms of whatever convention you've chosen for which way to be positive or negative. Where they get a little bit more difficult is where we do force versus time graphs. So, for instance, what you need to know about a force versus time graph, so if this is force and this is time, the area bound by that graph is equal to the impulse. And that should be pretty straightforward if we think about a graph like this, where it's just a rectangle. The force, which is this side here, times the time, that's going to give us the area. So when it's a rectangle, force times time, that's area. Oh, hey, force times time, that's the impulse. Things are a little bit more complicated when we have something that's a triangle. You're going to have to use your geometry, 1/2 base times height for the triangle. Or sometimes if we have something that is a curve, we look down the middle and we say about half the height, that's the average, and we just use that to approximate it. So you may have a problem where we give you a graph and you need to calculate the impulse using the graph, then come back to this equation, and the area bound by that graph is the left-hand side of this equation, and then maybe solve for something on the right-hand side. Remember, this is a positive impulse when it has a positive area, and then this would be here a negative impulse. And that's because it's below the horizontal axis here. And when we think about this, it's the force is negative times the time. So we would get a negative number on that problem. Right, there's an overview of target 2.